Firstly, I would like to thank you for taking the time to listen to me today. And in the name of MPS, I would like to welcome you to my presentation. After having given you some insight about the organization and the activities of MPS Microsystems, I will present you a selection of active solutions that have been developed by MPS Microsystems and that could be a way to solve your current challenge in optomechanics. Let me now introduce myself. My name is Patrick Ruffieux. I'm a product manager in optics and photonics here at MPS Microsystems, with some years of experience in optics and mechanics. Now, just a few words about MPS. The MPS Group is a Swiss-based company with a bit more than 400 employees. MPS belongs to the Lateral Group, the German manufacturer of micromotors, and is focused in the development and the manufacturing of miniaturized electromechanical systems. MPS is composed of 4 entities. MPS Watch, specialized in the development and the production of very small ball bearings and wheel trains for the watchmaking industries. MPS Microsystems, which develops and manufactures high-precision, high-performance and low-friction mechanical systems. MPS Precimed, focus on development and manufacturing of innovative instruments for traumatology and orthopedic surgery. MPS Décolletage, which manufactures high-precision parts for watches, connectors, and other industry sectors. The strength of MPS Microsystems is to provide innovative custom-built miniaturized systems. MPS Microsystems, as you can see, is acting across a wide range of industrial sectors, such as medical, optics and photonics, automation, aerospace and defense, and science. Now I would like to focus on some typical realization of lens actuators that have been developed by MPS Microsystems for answering different challenges in precision positioning optics. I will start with the multiple lens actuator that you can see here on the right part of the slide, which is a perfect example of a very miniaturized system. With a total length of less than 4 cm and lateral dimensions of nearly 2 cm, the system has roughly the size of a matchbox. This system has been realized as a complete scalable concept that easily allows the realization of bigger and other shaped devices, while keeping the acquired knowledge and the rich performances. With help of small 6 mm diameter Fowler stepper motors and our miniature ball bearings mounted on 2 mm diameter rods, the device allows the independent movement of 4 lenses over strokes of 2.5 mm for laser beam shaping applications. From this first example, a scaled-up device has been realized to answer another issue than the miniaturization of the mechanics. The device here consists of a laser beam shaping device for guiding system in defense applications. This dual lens actuator has strokes higher than 20 mm per lenses and repeatability is lower than 10 microns, without calibration needs. Here the main challenge was to allow this high precision to be effective in a very varying environment for airborne applications. To ensure such a functionality, the rigidity of the main frame has been increased at its maximum by fabricating the whole part in a single block. The lens holders move thanks to ball bearings fabricated by MPS Microsystems, and the driving mechanisms through Fowler motors linked to MPS ball screws. A smooth and accurate movement of the lenses is obtained, with a very high stability and lateral deviations below 5 microns. Another very interesting solution developed by MPS Microsystems, and mechanically very different from the previous examples, consists in a lateral positioner for Alvarez or freeform type lenses. This actuator is actually based on a flexible structure frame that allows a perfectly low lateral displacement of the lenses in the wish of focusing applications in microscopy. With that approach, a flat system is obtained with low friction and no backlash. The driving unit corresponds to 2 Fowler motors linked to MPS lead screws that achieve the rotational to linear movement conversion. The achieved stroke is plus minus 2.5 mm with a resolution that reaches 2 microns. A last example concerns a typical scientific application of active optomechanical solution. The device is a fiber positioning system employed in telescopes to collect the incoming light of stars in the purpose of proceeding to a spectrum analysis. Based on the SCARA-type geometry, the positioning of the fiber is ensured by the use of 2 mechanically independent rotational stages that allow the addressing of different positions within a specific area at the end of the positioner. The typical positioning accuracy at the end of the fiber is below 10 microns in the XY plane. The diameter of such a device has also been reduced at its maximum to allow the best possible resolution when joining side by side several actuators at the focal plate of the telescope. Here, the presented device has a wall diameter of only 8.5 millimeters, which represents a very challenging integration issue that has been successfully fulfilled. To summarize the customization, the reliability and the precision is the core business of MPS Microsystems. And all the presented devices here show you the capabilities as well as the adaptation of MPS Microsystems to various challenges that are commonly faced by industries. I hope that this short overview of some of our optomechanical solutions could give you ideas for your future developments in active optics. Thank you for your attention, and please feel free to ask us your questions or requests at the following addresses. Thank you for your attention.